Today we finish up our lessons on linked lists. We're going to create two more variants, circular versions of our singly and doubly linked lists. Starter code is provided below. Taking a quick look, we see we have copied and pasted our non-circular versions, but have also added a new interface called CircularLinkedList. It is empty, but extends the list interface. It's useful because it defines a type that indicates to the implementer that these classes should be circular when implemented, but is otherwise a regular list. It also means that we can explicitly state when we want a circular linked list, but don't care if it's singly or doubly linked, just that it operates as a list but is also circular. For contains, get, is empty, etc., all of those will remain the same. Even our next and previous methods should work just as is. The biggest change is going to be with our add and remove method. This applies to both singly and doubly linked lists. For our head node, we'll need a point its previous to be the tail in the doubly linked version. The singly, there is no previous. And then for the tail node, its next must be the head for both versions. Open up the circular singly linked list class to get started. For now, let's scroll down to our add method. Then in the if block before returning, add this.tail.setNext new node. Then outside of the if check, add this.tail.setNext is this.head. Now, in our add first, after we reset the head, we also need to point the tail to this new head. So this.tail.setNext equals this.head. And then add at location, well, we're 99% of the way there, but we need to repeat that add at the end logic. So we're just going to do if I equals this.size, then add object, and return, so we don't need to rewrite the logic. We just use something we know should work. And then moving down to the remove it location, we're going to do that same check we just added for add at location. If I equals this size, remove last and return. Then remove first, we're going to want to do this.tail.setNext is this.head to point to the new head. And then in remove last, we're going to do the same thing. Generally, this is pretty straightforward. We just know that our tails and heads are attached, so we just got to make sure that we're maintaining that every time we add a node or remove a node. Now we go into our doubly linked lists, and we're going to go through all of the methods in the same order. We're going to add all the same logic we did in the circular linked list, but we're also going to do this.head.setPrevious this.tail in all of those locations. And don't forget to do the if I equals size check and then add or remove last calls as well, since this update works not only in the singularly linked list, but the doubly ones as well. And so this is all more or less a copy-paste job. I'm going to fast forward through it. Now that we're done with that, there are some issues, particularly around the remove methods. We have this big edge case when we have a list of size 1. The circular nature of these objects means we can't just move our node's next and previous values around because, well, it's circles, so we might accidentally set a value when we meant to set it to null. Instead, we're just going to check, hey, is size equal to 1? Okay, well, let's just set everything to null because we're going down to size 0. Otherwise, we're going to do this head-tail reassignment logic we already have. And then this is going to be the same for both add and remove in both singly and doubly linked lists. Now, because the code modifications were so brief, we can go into a bit more detail into why we might want this style of list. Well, think about things that don't have an inherent end, like a turn-based game, especially one with more than 2 players, like Monopoly. 2 players you can probably do with a Boolean, but with 3 or more it gets a little bit more complicated. Using a circularly linked list, you can easily navigate forwards, or in a doubly's case, backwards, one person at a time, and you always will maintain a consistent ordering on that. Player 2 always goes after player 1, and say there's 4 players after player 4, player 1 would be the next person because that would be the head node that the tail points to. You can infinitely loop going forwards or backwards until some external factor says we're done, like someone wins Monopoly or someone wins Uno. But that means we need to be extra careful when we use circular lists because of the issue of infinite loops and breaking our code. Always make sure you have some exit case because these lists have no actual end. The end must be defined by you explicitly in the loop. Even if it's just, oh, we've hit the head node 5 times. Just something that tells you to exit your code. Next week we're going to do stacks, and then queues, and then we're going to move on to our dictionary objects. So keep an eye out for those in the near future. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.